Hello and welcome to this experiment. In this video we are going to build the smallest and simplest electric train. This is a popular experiment that will help us explore and understand the fascinating world of electromagnetism. This electric train we are about to study is a type of homopolar motor and it's related to various concepts such as electromagnetic induction and eddy currents. Homopolar motors are direct current electric motors with two magnetic poles. They were the first electric motors created in 1821 by the famous scientist Michael Faraday. They are usually used in turbines, toys, and small engines. In order to make this easy experiment, we will only need three elements: a long enough copper wire, an average AA battery, and two cylindrical magnets. As you can see, we will need to curl the copper wire in order to make a solenoid, which we will use as the circuit. Doing this is as easy as twisting it around the long cylinder. This is all the preparation we need before the experiment. Oh, and careful with the magnets. Now let's start with the experiment. When entering the battery, we must pay attention to its direction. If we do it backwards, it will be spitted out because the force will be in the opposite direction. We can also close the circuit to create a closed loop the battery will repeat until it discharges. You will be wondering how this works. It is very simple. The magnets act as conductors, allowing an electric circuit to be formed between the battery and the copper coil, through which an electric current flows. This electric current induces a non-uniform magnetic field stronger in the center. The magnets both face the same force with opposite direction, but as both magnets' north poles are closer to the center, they experience a stronger force than the south pole. For this reason, the train will be accelerated in one direction. But this acceleration won't be constant, and the train will reach a terminal velocity. This is because the moving magnetic field of the magnets will induce a new electric current through the wire, which at the same time will induce a magnetic field opposite to the first one. So at the end, the net force of the train will be zero, and it will move at constant speed. The phenomenon can be better seen when throwing a magnet through a non-ferromagnetic tube, such as aluminium. The generated eddy currents slow down the free fall of the magnet. This has been our little experiment. Thank you for watching and goodbye.